Welcome, everyone. We already have a few participants joined in. I think a few more will arrive in the next minutes, but we're going to start. So welcome and thank you for joining us today for the webinar on facade fire safety, choosing the right method with Lars Bostrom from RISE. My name is Sarah de Bischrichen, Public Affairs Officer at FireSafe Europe. FireSafe Europe is a broad and cross-sectorial alliance of fire experts, firefighters, European associations, and international companies. And our mission is to improve fire safety in buildings for people. Our speaker today, Lars Bostrom, currently holds the position of Manager of Mechanics Research at RISE. He has a very long experience in the field of fire testing and has more than 15 years of experience as a manager of fire research at RISE. So RISE was the lead contractor for the European Commission study to develop a European approach to the fire assessment of facades, and Lars was one of the authors for the report. Just a little housekeeping before we get properly started. Everyone will be muted throughout the webinar, and as such, if you have any questions during the presentation, please type them in the chat box in Zoom. We will address them after the presentation during the Q&A session at the end. If you want to tweet, the hashtag is #TheRightTestForFacades. And the webinar will also be recorded. Registrants to the webinar will be sent the direct link. I'm going to put all these housekeeping rules into the chat so you can see them. And without further ado, we will give the floor to our speaker. Lars, over to you.
Thank you very much, and I hope you can hear me. Yes, welcome to this webinar on facades fire safety and choosing the right assessment method. Before starting, we can say that you can see in the title that we have choosing the right assessment method, and that is because in this project it was two methods that were developed, but I will come back to that just in a moment. So if we start with the aim of this study that we preferred, it was to develop a methodology for the fire safety of facades, and that was to include both a test method and a classification system. It was also supposed to be based on the British standard 8414 and the German standard DIN 4102-20. And of course, it should be applicable to all the member states and all the regulations that are currently in use in all the member states. It was also important that it should not cover any of the details given in the classification standards on fire resistance and reaction to fire, the standards EN 13501-1 and -2. So this was the aim of the study, and we can say we interpreted the aim a bit differently in the project group and what the Commission wanted. And that is why we ended up with two different solutions. The Commission, they wanted to have a method that was completely based and totally based on the current British and German methods, while in the project group, we saw it that we should use those two methods as a basis and develop something new. In the project group, we had a number of partners. I was acting as a project leader, but we had also representation from Germany by Anja Hoffmann-Burlinghaus, from UK with Sarah Caldwell, and France was participating with Roman Shiva, and Hungary, from Hungary we had Peter Toth and Istvan Moder. And then we had some partners here from RISE as well, helping me, Johan Sjöström, Johan Andersson, and David Lang. So it was a quite small group, but a very good group, and we have had a very good collaboration within this group. It was a tough project because we had a very limited time. Both a limited time and a limited budget. So in principle, we were supposed to do all this work in half a year. It ended up in the end that it took some time longer. So the final report was delivered shortly before the summer this year. And it was supposed to be delivered at the end of last year. So it was delayed half a year. But nevertheless, we finalized it, and you have probably all seen the report. So if we go into some details now, we have, first of all, the regulations that we had to cover. And we made a study of all the regulations in Europe, and we had a number of subcontractors. So we had some contractors in principle in every of the member states to give to help us to define what the regulations are in the different member states. And we could see that there were a number of states that have requirements where medium-sized or a full-size test is required. And that was the Slovak Republic, Hungary, Switzerland, Sweden, Austria, Germany, Finland, Poland, the UK, France, Denmark, and Norway. The regulations are a bit different. We can see that the regulations on flame spread, vertical flame spread, it is used in all of these countries that have some kind of a full-scale test. When it comes to flame spread in horizontal direction, some countries have regulations on that. Most countries have a regulation on flame spread within the facade system. And then we're coming down to some more particular points. For example, the junction between floor and facade. There are some countries that are regulating there. Smoldering fire, we have only one country that has regulations on smoldering, and that is Germany. And here we have a dilemma because smoldering is covered both in their facade test, and we have an European standard test also for smoldering. So the question of how to solve this, we don't know yet. Falling parts is a number of countries have regulations on falling parts. It has been discussed also whether smoke should be assessed with this method. And we can see that 2 countries have something in the regulation about smoke, but they are only stating that the smoke shall be observed, but they do not have any requirements for assessing smoke production in the facade tests. Then we come down to some details on how to measure on the tests. We have some different heat and or temperature or heat flux measurements that are used. And we can also see that in some countries we also have to incorporate different kinds of detailing in the test. For example, window openings or fire stops and that kinds of details. So this shows a menu of what characteristics that are regulated in Europe at present. So we had to find a methodology where all these characteristics could be included. So the result then was 2 different methods. One that is called the proposed method, and that is based on the requirements from the European Commission. And that was a requirement that came quite late in the project. We had almost finalized the work when we were asked to make this method as well. And that method should be fully based on the British and the German methods in the sense that the methods should be kept as they are, no changes to the method, but only that we should add some extra measurements and perhaps add something extra that could be used when needed. So in principle, it is a copy of the British and the German method, and we have only added how to measure, for example, falling parts, how secondary openings such as windows could be incorporated in those tests. The other alternative is what is called the alternative method. And this was a proposal from our project group. And this method, it is based on the British and the German methods, but we try to combine them. So we have one single rig, so it looks the same. The geometry of the test rigs used in the British and the German methods, they are it's not a big difference. There are some differences, but they are quite similar. So we merged them and came with a proposal so we'd only have one test rig. The big difference between the two methods is that they have different fire exposures. The British standard uses what we call a large fire, and the German method, medium-sized fire. So in this alternative method, we can use both these fire exposures. We also managed to make a simple classification that could be used for this alternative method. And if we look little on what they look like, so the proposed method, that is exactly the British and the German methods, according to those standards. And for the large fire exposure, the British method, we have added then an optional way of introducing a secondary opening, that is a window opening. And we have also added how to measure falling parts. But these are both optional then. For the medium fire exposure, the Dean method is used, and there we have added an optional measurement of falling parts. In the alternative method, if you look on the right side of the picture, we can see that it is the same test rig that is used. The only difference is the size of the combustion chamber. So this is easily adjusted depending on what kind of test you want to do. If you want to do the large fire exposure or the medium fire exposure, you can do them both in the same test rig. It is just how you build up the combustion chamber. So you have both alternatives in the same test method. Then we're coming to the classification system. That was quite difficult when we're going to use the German and the British standards, because you can't. You get two different classification systems. You get one for the British method, and you get one for the German method. And here we have a number of parameters that has to be incorporated. You have if you have window openings, if you have junctions, if you're looking on falling parts and burning droplets, if you're going to include smoldering characteristics. So you get a quite complicated classification system, but it is doable. With the alternative method, here we get a much simpler classification system, where you end up with just 4 classes. And you can say if you make the large fire exposure test and you fulfill the requirements for falling parts, then you cover all the other classes. That is not possible with the proposed method. So if you do a large fire exposure test with the proposed method, it will not cover the medium fire exposure. If we look on advantages and disadvantages with the two alternatives, so we can say that with the proposed method, that is that keep the German and British standards as they are, we get an advantage that the historical data can be used. And that is, of course, very good for those who have made a lot of tests. We can also say that it is easy to make these methods into standards since the methods already exist. But there are some disadvantages as we see it from the project group. And that is that it is only a limited number of countries that can use historical data, because it is only the ones that have used the British and the German method, and it is just a limited amount of the data that exists today that can be used again. We also think that it could be difficult to get acceptance by the member states because this method has already been proposed in the IOTA work earlier, and it did not succeed in that. So we see it as difficult that it should be successful now. Therefore, we see this as a disadvantage. We also think that more tests will be necessary to be carried out, since it is not possible to cover both these methods within one system. So if you're doing tests with a large fire exposure, it does not cover the medium fire exposure. So that will make it that you have to do more tests. And furthermore, the classification system will be quite complicated. And here we could see also in the comments we received during the project that a lot of comments was regarding the classification system. Many wanted a very simple classification system. With a complicated classification system, it will be more difficult also for regulators and industry to work with this. If we then go to the alternative assessment method, here we can first look on the advantages. We will minimize then the number of tests to be carried out. It is one successful test can cover all the regulations in Europe. We think it will be easier to get acceptance by the member states also for this alternative assessment procedure. And the large fire exposure test also covers the medium fire exposure test. And that, of course, that limits the test burden for the industry. And we will get a simple classification system. What I think is important, it is that the test method will be upgraded now to the current knowledge on facade testing. So it will be a modern test method. Of course, there are some disadvantages to go in this way as well. We will not be able to use historical data. And probably there will be some more work needed to ensure repeatability and reproducibility. And it might need some more work than to go for the proposed method. So if we look into the future, so we can see that more work is needed. And it doesn't matter which of the two alternatives that is chosen. We have to make first of all, a theoretical round robin. And with that, we mean that we have to see that the standard is written in such way that everybody interprets the standard in the same way. And that can be made in a theoretical and not so costly way. Further studies will be needed. And that is for both the alternatives. We have to check what in environmental conditions can the test be carried out in. Can we do the test outdoors, or is it necessary to make them indoors? And what requirements do we have on ventilation and wind, temperature, and so on? We have a question about fuel source and that is a question for both alternatives. In the German method today, it is possible to run it with both wood cribs and with gas burners. And how do we ensure that you get the same result with both fuel sources? The ventilation conditions. In the German method, we have a ventilation to the fuel chamber. This is not the case in the British method. And this must be checked also. How can we ensure that we get the correct ventilation conditions? But because that will affect the fire exposure to a large extent. We also have to look on the mounting of thermocouples. That is a bit different. And there are also some other questions that has to be solved before we can write it into the standard. And then when all these studies has been done, we will also need to carry out an experimental round robin to ensure that the method is robust enough and that we get good repeatability and reproducibility, at least as good as needed. And we have made a program for this work and also calculated the cost for it. And it's not a big difference between the two alternatives. Both the time needed and the costs are quite similar. So now I leave the floor for any questions.
Thank you, Lars, for this very insightful presentation. I'll go ahead, well, you'll go ahead and address some of the questions. I'll read them out in order so that we can take them in the order of arrival. So first we had a question from Tommy Kjar saying, in your opinion, which European country should we look for to see the most safe regulation regarding facade, fire safety of facades? And who is the worst in Sweden? Are you building high-rise buildings made of wood?
Regarding the regulations, we are not talking about regulations here at all. The regulations, they are a national question, and it is quite different. What we are doing here is to develop a test method where we can get a classification system, and I think that these methods both will work quite well, and we will get relatively good facade systems if they pass these methods. And it doesn't matter if it is the alternative method or if it is the proposed method. They will probably work quite well. I don't remember what was more in the question.
I think the question was more related to best practices in member states, but I think that the report actually covers this quite well. We might go into the second question by Quentin de Hout, saying, could you not simplify the classification system for the proposed method? Why do you say that the large-scale test cannot cover the medium scale? Testing and classification are two different parts of the story. You can simplify the classification of the proposed method.
It might be possible that it can be simplified further on, but this was not what the Commission wanted. They wanted to keep the different classes. We have one thing, for example, in the proposed method, we are always using the secondary opening. So that means that it is one characteristic that is always included and must always be fulfilled. That is an option in the proposed method. So there you have a difference. It was also for the proposed method that he wanted to have different levels on falling parts and on the burning droplets, and they wanted to keep them separated, which made it furthermore complicated. So this was more of a question to the Commission that this was what they wanted to have. But of course, it would be possible to simplify it a bit further. The two methods are quite different regarding some things that makes it difficult to ensure that you can cover that the large scale test should cover the medium fire exposure test. It might be possible that the large fire exposure could cover also the medium fire exposure, but we do not know. We do not have any research done on that. And for example, the question is because they are measuring the temperatures for the assessment at different levels and different points. So there are a number of differences between the two methods that makes it difficult to compare them. That is overcome by the alternative method where we always do the measurements at the same position and we have the same requirements, for example, for temperature and so on.
Thank you, Lars. Another question we have from Chris Mars is, did the group consider the points raised by the risk authority study on the BS 8414 test?
No. That is something that we have not considered at all.
Okay.
It might be we had Sarah Caldwell in the group, and if she had it in her mind, it might be possible, but it was not any document that we have gone through. I know that there has been a lot of publications lately on the British standard, and that material has come out after we have done our work. So we started our work. It was before the disaster in London.
Mm-hmm. We then have two questions from Arjen Stevens and Quentin Deurs related to the time needing, saying you've mentioned that more work might be needed for the alternative method. How long would this take? And is it not inconsistent to say that the same amount of work is needed for the alternative method and then say that costs are equal when more work might be needed?
It's different kinds of work that is needed depending on which alternative we are choosing. So we have made we estimate that a time of 2 years will be needed. And it really doesn't matter which method you're choosing here, because for both methods you have to do the round robins. And that doesn't matter if it is the alternative method or the proposed method. The work that we need to do for getting a good enough reproducibility and robustness and so on, it is a little bit different between the two methods, but we estimate it's not such a big difference in the amount of work that we need to do, or the amount of testing that is needed. It's different kinds of tests that is needed and different kinds of studies. So we think that the time and the cost, it's not such a big difference.
Thank you, Lars. I have a question here from Peter Maas saying, do I understand correctly that more fundamental research independent from existing testing method would be useful or even necessary?
I don't think we need more research, really. We have to define certain we have to define certain aspects related to the test. For example, we have to define what kind of environmental conditions will we need. Can the test be done outdoors or must it be done indoors? I don't see that as really research, but we have to define this and see, for example, wind speed. How does it affect the results? What wind speed can be acceptable? We also have, for example, if we go for the proposed method, where we can use both gas burners and wood cribs, there we have to ensure what kind of tolerances do we have to have on the timber, for example, in the wood cribs, in order to ensure that we get the same heat exposure in both cases. So it's more of a, not really research, but we have to figure out all these or answer these questions. So there are a number of questions to see that we can get a robust method, but it is not any fundamental research that is needed. We also have a question about burning droplets, for example. There it is important that if you have a combustible material falling down from the test specimen, that they should not start to burn due to the radiation from the heat source from the test rig. So there we have to see how can we solve that, and the solution is to lift up the test rig some distance from the floor level. But how far do we have to lift it up in order to ensure that the material doesn't ignite from the radiation from the heat source?
Thank you very much, Lars. We are getting towards the end of this webinar. I see that there are a few more comments. What we will do is to address those in writing at a later stage. We're very happy that you joined us today. And we wanted to also announce that you can already register to the next data webinar series, which will be starting in November. Also, a big thank you to Lars for your presentation today, which was extremely insightful indeed. As already mentioned, we will respond to the remaining question together with Lars in writing at a later stage. Thank you very much, everybody, and have a lovely rest of the day.